Preparing for an AI technical consultant interview? You've reached Interview Guide, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How do you approach a client's request to add AI to their business process? I start by translating the AI request into a business problem. I ask what decision, workflow, or customer experience they want to improve, who owns it, and how success is measured. Then I check data readiness, latency needs, compliance constraints, and integration points. Only after that do I propose options like automation, prediction, search, or generative AI. This avoids shiny object projects and keeps the engagement tied to ROI. While answering, focus on discovery before solutioning. Business pain, measurable outcomes, user workflows, data availability, feasibility, risk, and how you convert vague AI interest into a scoped use case. Question 2. How would you decide whether to use a traditional machine learning model, a hosted LLM, or an open source model? Model selection starts with constraints, not hype. If the task is classification or forecasting with structured data, I prefer simpler supervised models or AutoML baselines. For language-heavy tasks, I compare hosted LLMs, open-source models, and fine-tuning only if prompting or RAG fails. I score choices on accuracy, latency, cost, security, explainability, and operational effort. The best model is the one that meets business requirements reliably, not the most advanced one. Make sure to cover task type, data modality, accuracy needs, latency, cost, privacy, explainability, vendor lock-in, infrastructure maturity, and why simpler models may outperform generative AI in many cases. Question 3. What questions would you ask to assess whether a client is ready for an AI implementation? Data readiness is usually the biggest delivery risk. I ask whether the client has the right data, enough history, clear labels, stable schemas, documented lineage, and permission to use it. I also check business ownership, process maturity, cloud readiness, security policies, and adoption appetite. If the foundation is weak, I recommend a phased roadmap. Fix data pipelines, build governance, prove value with a pilot, then scale the AI solution. In your answer, talk about data availability, executive sponsorship, process maturity, compliance constraints, integration readiness, user adoption, budget, success metrics, and whether the organization can operate the solution after launch. Question 4. How would you explain retrieval-augmented generation to a non-technical stakeholder? I describe RAG as giving an AI assistant an approved company library before it answers. Instead of relying only on what the model learned during training, we search relevant internal documents, pass that context to the model, and generate a grounded response. This improves accuracy, supports citations, and keeps content fresh without retraining. It still needs good document quality, access controls, and evaluation, because retrieval errors can become answer errors. Be sure to mention grounding LLM responses in enterprise documents, retrieval from vector stores, reduced hallucination, freshness, access control, citations, and why RAG is different from fine-tuning. Question 5. A client complains that their chatbot gives confident but wrong answers. I would separate model behavior from retrieval behavior first. I would inspect failed conversations, check whether the right documents were retrieved, review chunk size and metadata filters, and test prompts for overconfident language. Then I would add citations, refusal rules, confidence thresholds, and escalation to a human for low certainty cases. Finally, I would create a regression test set from real failures, so every prompt, model, or knowledge-based change is evaluated before release. While answering, cover hallucination causes, prompt design, retrieval quality, document chunking, grounding, evaluation sets, confidence thresholds, fallback behavior, human escalation, logging, and continuous monitoring. Question 6. How do you define success metrics for an AI project? I define success at 3 levels. Business metrics show impact, like reduced handling time, higher conversion, fewer fraud losses, or better agent productivity. Model metrics measure technical quality, such as precision, recall, groundedness, or answer relevance. Operational metrics track latency, uptime, cost per request, and escalation rate. I always establish a baseline before the pilot, agree on target thresholds, and make sure the metric is tied to a decision the business actually controls. Make sure to distinguish business KPIs from model metrics. Include baseline comparison, user adoption, quality, cost, latency, risk, operational metrics, and how metrics change between pilot and production. Question 7. How would you structure a proof of concept for an AI solution? A good POC is narrow, measurable, and realistic. I start with one high-value workflow, define a clear hypothesis, identify representative data, and agree on acceptance criteria before building. The POC should test the riskiest assumptions: data quality, model performance, integration complexity, user experience, and compliance. I avoid over-engineering, but I document what must change for production, such as monitoring, access control, scalability, and support ownership. In your answer, talk about narrow scope, representative data, hypothesis, acceptance criteria, timeline, stakeholder alignment, technical architecture, security review, demo value, and production readiness gaps. Question 8. What is your approach to AI solution architecture for an enterprise client? I design the architecture around the business workflow first. A typical enterprise AI solution includes data connectors, pre-processing, feature or embedding pipelines, model inference, an API layer, user-facing applications, monitoring, and feedback capture. I also design for identity management, audit logging, encryption, rate limits, and human review where risk is high. The goal is not just a working model, it is a maintainable system that fits the client's operating environment. Be sure to cover end-to-end architecture, data sources, pre-processing, model serving, APIs, security, orchestration, monitoring, human review, integration with existing systems, and cloud or hybrid deployment decisions. Question 9. How do you handle client concerns about data privacy and security when using generative AI? I start by classifying the data and identifying what can legally and safely leave the client's environment. For sensitive use cases, I recommend private networking, encryption, role-based access, prompt and response logging with controls, PII redaction, and vendors that contractually exclude training on client data. Sometimes the right answer is a private model or on-prem deployment. Security decisions should be part of architecture, not a late-stage checklist. While answering, focus on data classification, PII handling, encryption, access control, private endpoints, vendor terms, data retention, auditability, redaction, compliance, and secure deployment patterns. Question 10. When would you recommend fine-tuning an LLM instead of using prompt engineering or RAG? I recommend fine-tuning only after simpler options are tested. Prompt engineering is best for quick behavior control, and RAG is best when answers need current or proprietary knowledge. Fine-tuning helps when the model must consistently follow a specialized format, tone, or task pattern, and we have enough high-quality examples. It is not the right tool for injecting constantly changing facts. Fine-tuning adds evaluation, versioning, and retraining responsibilities, so the benefit must justify the operational cost. Make sure to compare prompt engineering, RAG, and fine-tuning, including use cases like style adaptation, task consistency, domain behavior, cost reduction, data requirements, evaluation, and maintenance burden. Question 11. How would you evaluate the quality of an LLM-based application? LLM evaluation needs more than a single accuracy score. I build a test set from real user intents, edge cases, and known failure modes, then evaluate relevance, groundedness, completeness, safety, and format compliance. For critical tasks, I combine automated scoring with human review because model-graded results can be biased. I also track production signals like thumbs-down rate, escalations, latency, and cost. Evaluation must be continuous because prompts, documents, and models change over time. In your answer, talk about offline test sets, human evaluation, automated judges, groundedness, relevance, toxicity, safety, latency, cost, regression testing, production feedback, and metric limitations. Question 12. A stakeholder wants 99% accuracy for an AI system. How would you respond? I would first clarify what they mean by accuracy and which errors are most expensive. In many AI systems, false positives and false negatives have very different business impacts, so precision, recall, or human acceptance rate may be better metrics. I would compare against the current process baseline and propose confidence thresholds, human review, or fallback paths for risky cases. The right target is not a round number. It is the performance level that creates safe, measurable value. Be sure to mention clarifying what accuracy means, error types, business tolerance, baseline performance, precision versus recall, human-in-the-loop design, cost of mistakes, and realistic expectation setting. Question 13. How do you translate technical AI concepts for executives and business users? I translate AI concepts by anchoring them to decisions the audience already understands. For executives, I focus on value, risk, timeline, investment, and operating model. For business users, I explain how the tool changes their workflow and where human judgment remains important. I use simple analogies, examples from their data, and trade-off language instead of model jargon. Good consulting communication is not dumbing things down, it is making the decision clear. While answering, focus on business framing, analogies, visual explanations, avoiding jargon, connecting trade-offs to cost and risk, tailoring detail by audience, and checking understanding. Question 14. How would you prioritize multiple AI use cases for a client? I use a value feasibility risk lens. High-value use cases with available data, clear owners, and low integration complexity are strong candidates for early pilots. Highly regulated or data-poor ideas may still matter, but they need more groundwork. I also consider adoption effort and whether the use case creates reusable assets, like a document pipeline or common AI platform. A good roadmap balances quick wins with foundational investments that support larger transformation. Make sure to cover value versus feasibility, data readiness, risk, strategic alignment, implementation complexity, stakeholder ownership, regulatory exposure, quick wins, portfolio thinking, and roadmap sequencing. Question 15. What are the key components of an MLOps or LLMOps pipeline? An AI system needs an operating pipeline, not just a notebook. Core components include data versioning, pre-processing pipelines, experiment tracking, model or prompt registry, automated evaluation, deployment automation, monitoring, and rollback. For LLMOps, I also track prompts, retrieve documents, embeddings, model versions, token cost, and safety evaluations. The goal is reproducibility and control. When performance drops or a model changes, the team should know what changed and recover quickly. In your answer, talk about versioning, data pipelines, experiment tracking, model registry, CI/CD, deployment, monitoring, drift detection, prompt management, evaluation, rollback, and governance. Question 16. How do you manage bias and fairness risks in an AI implementation? Bias management starts before modeling. I check whether the training data represents the affected population and whether labels reflect historical unfairness. During evaluation, I compare performance across relevant subgroups, not just average accuracy. Mitigations can include data balancing, threshold adjustments, explainability reviews, and human oversight for high-impact decisions. I also document limitations and monitor outcomes after launch. Fairness is not a one-time test, it is part of responsible AI governance. Be sure to mention representative data, sensitive attributes, fairness metrics, subgroup analysis, human review, explainability, governance, documentation, regulatory context, and ongoing monitoring after deployment. Question 17. How would you estimate the cost of running a generative AI solution in production? I estimate cost from expected usage patterns. For an LLM app, I calculate input and output tokens per request volume, model pricing, embedding generation, vector database costs, orchestration services, monitoring, and infrastructure. I also include human review and support costs if the workflow requires them. Optimization levers include prompt compression, caching, smaller models, batching, retrieval filtering, and routing simple tasks to cheaper models. Cost modeling should be revisited after real usage data arrives. While answering, focus on token usage, request value, model pricing, embedding costs, vector database costs, caching, latency tiers, monitoring, infrastructure, human review, and cost optimization levers. Question 18. A client's legal team is blocking an AI rollout. How would you work through it? I would treat legal as a design partner, not a blocker. First, I would clarify their specific concerns: data exposure, IP ownership, regulatory compliance, explainability, retention, or liability. Then I would provide data flow diagrams, vendor terms, control mappings, audit plans, and proposed guardrails. If needed, I would narrow the use case or start with anonymized data and human review. The objective is to reduce risk enough for a responsible rollout, not to bypass governance. Make sure to cover stakeholder alignment, risk assessment, data flow diagrams, vendor review, compliance mapping, audit logs, explainability, phased rollout, guardrails, documentation, and collaborative problem solving. Question 19. How do you handle a situation where the AI model performs well in testing, but poorly after deployment? I would first check whether production inputs match the test data. Common causes include data drift, training serving skew, new user behavior, missing fields, latency failures, or downstream integration changes. I would inspect logs, segment failures by user group or workflow, and compare model confidence and outcomes over time. If impact is serious, I would roll back or route to human review. Long-term, I would add drift monitoring, retraining triggers, and stronger release validation. In your answer, talk about data drift, training serving skew, feedback loops, monitoring, segmentation, logging, rollback, retraining triggers, user behavior changes, and incident response. Question 20. Why should a company hire an AI technical consultant instead of just buying an off-the-shelf AI tool? Off-the-shelf tools can be useful, but they rarely solve the full business problem alone. An AI technical consultant helps define the right use case, validate data readiness, compare vendors, design integrations, manage risk, and align stakeholders. I also help the client understand build versus buy trade-offs and avoid expensive pilots that cannot scale. The value is in connecting strategy, architecture, implementation, and adoption, so AI becomes an operating capability, not just another subscription. Be sure to mention fit-to-process, integration, data strategy, governance, customization, vendor selection, ROI, change management, risk reduction, and bridging business stakeholders with engineering teams. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.